Okay, this is Chapter 5, Lesson 4. Chapter 5, Lesson 4. So, please make sure you put 5.4 at the top of your notes and today's date. Write your objective. Students will use factoring to find common denominators. Factoring. All right, let's talk about that factoring for a second. First of all, I need you to remember what factors are. Factors are numbers that you can multiply together for a product. So for instance, 5 times 4 is 20. And hold on. And the factors are 5 and 4. These are factors. Okay? So basically what this means when you have factors is that factors are numbers that are can be divided evenly into the product, which is 20. Okay? So a factor of 20 is 5. Another factor of 20 is 4. And by the way, another factor of 20 is 2, because I can multiply 2 times 10. And therefore, another factor of 20 is 10. 1 is a factor of all numbers, because when I count by 1, I say all numbers. So I can multiply a number by 1 and get 2. 1 times 2. I can multiply 1 by a number and get 15. 1 times 15. So 1 is a factor of all whole numbers. 1 is a factor of all whole numbers, all integers. So I can multiply 1 by a negative number and get the negative number. So if I were trying to find factors of negative 20, 1 and negative 1 are both factors of 20. Negative 20, sorry. So when we're using factoring, we're finding the factors of a number. That's what we're doing, finding the factors of a number. So factoring is finding factors. And we use factoring in fractions. So today we're going to be working on factoring with fractions. Writing fractions in simplest form. A fraction is in simplest form when 1 is the only common factor of the numerator and the denominator. So we're finding common factors of both 2 and 3. That means we're finding numbers that are factors of 2, numbers that are factors of 3, and figuring out what the common factors are. The factors of both 2 and 3 as this numerator and denominator. So for instance, factors of 2 are 1 and 2, and I do want you to write all this down. Okay? Factors of 2 are 1 and 2, factors of 3 are 1 and 3. So the only common or same factor of 2 and 3 is 1. That means 2/3, the fraction 2/3 is in simplest form. I cannot make 2/3 any smaller of an equivalent fraction than what it is. So, example 1 is simplifying fractions. In other words, finding all those common factors. I'm going to show you, don't write all this down please. I hope you didn't already pause it. Don't write all of this down. I'm going to show you 3 different methods for simplifying fractions. Once you watch the video and see all 3 methods, I want you to think about which one makes the most sense to you and just write that one method down. You only have to use one of these methods. Okay? So, whoops. How'd that happen? All right, so here's you can write example 1, simplifying a fraction, and simplify 12/20ths. You can write that, but just don't write the methods yet. The first method is to find a common prime factor. To find prime factors, remember, we do factor trees. So I did a factor tree of 12. We could do 3 times 4, 6 times 12, so we have 3. 2, and 2. So that's where I got these from. So factors of 12 are 2, 2, and 3. And then factors of 20, another factor tree. Factors of 20 are, I could do 2 times 10, 2's prime. 10, I can multiply 2 times 5. So now I have 2 and 5. So 2, 2, and 5 are the prime factors of 20. 2, 2, and 5, which is where I got those from. So I did factor trees to find these. So this is one way. Now, once I have my factor tree, I can, and I have my prime factors, I can cancel them out. So I have a 2 and a 2, a 2 and a 2, and now what's left? 3/5. Then this is how I reduce 12/20ths to 3/5. So that's one way. So if you decide this is the way for you, this is the way you're most comfortable doing it, then you can pause the video and write this one down. Okay. Next, method 2. Method 2 is to find the greatest common factor of 12 and 20 and divide by that number. So factors of 12. Factors of 12 are numbers I multiply to get 12. 1, 2, 3, 4, 6, and 12. Factors of 20 are 1, 2, 4, 5, 10, and 20. Now what are the common factors? They have 1 in common, they have 2 in common, they have 4 in common, and it looks like that's it. So what's the greatest common factor of 1, 2, and 4? 4 is the greatest. So 4 is the GCF of 12 and 20, and we divide by 4, as you can see here. So I got that 4 by finding the greatest common factor of 12 and 20. All right. So 12 divided by 4 is 3. 20 divided by 4 is 5, 3/5. So we divided them both by 4 and got 3/5, same answer as method 1, 3/5. And now method 3 is something maybe a little new to you. For method 3, we can draw an upside down division problem with both the numerator and the denominator as the dividend. So, again, just so you remember, we are reducing the fraction 12/20ths, okay? I draw an upside down division problem. That's not upside down though. I draw an upside down division problem. I put 12 and 20 both here, 12 and 20. I think of a number that will go evenly into 12 and 20. And the first number that most of you would think of is 2, because they're both even. So we're going to start with 2. 2 goes into 12 6 times, and 2 goes into 20 10 times. Remember, anytime you divide by 2, you're just cutting a number in half. Okay? So now I have 6 and 10. Well, 2 can go into 6 and 10 also. So I draw another upside down division problem and put 2 into this one now. 2 goes into 6 3 times. 2 goes into 10 5 times. And there's my new fraction 3/5. 3 over 5, 3 over 5. The part that I need you to remember, and I know this is difficult because we sometimes forget what that equal sign means. This says now that 12/20ths is equal to 3/5. So, what that means is if I have 12/20ths of a pizza and somebody else has 3/5 of a pizza, we both have the same amount. Just 12/20ths is 20 slices, 12 out of 20 slices. So those 20 slices obviously are going to be cut pretty small for a pizza to be cut into 20 slices. However, the same size pizza on the other one is cut into 5 slices. Well, if it's only cut into 5 slices, those pieces are going to be much larger. So whether you have 12 out of the 20 slices or 3 out of the 5 slices, either way you have the same amount. Those are equivalent fractions. So anytime you reduce a fraction by dividing by the numerator and denominator by the same number, you have an equivalent fraction. Okay? So choose one method, method 1, method 2, and method 3. Choose one of those and write that method down as the one you're going to use to reduce fractions into simplest form. Example 2, simplifying variable expressions. So what happens when we add a variable to it? 4x squared over 6x. Remember, that means 4 times x squared over 6 times x. I'm going to use the prime factor method here, although you do not have to use that method. So whatever method you wrote down in example 1, use that method here also. And I will show you what I mean. Write example 2 and all of this. Right, simplify the expression. Write what the expression is. So, now you don't have to write this letter A unless this is the method you're choosing. Okay? If you choose to use the prime factorization method, then you write this. If not, then wait and don't write this yet. 4 times x squared. The prime factors of 4 are 2 times 2. And x squared means x times x times x. 6x, the prime factors of 6 are 2 and 3. And I have 1x. Now I cross out all of my common factors. So 2 and 2 I can cross out. X and x I can cross out. Now what's left on top? 2 and x. 2 times x is 2x. And 3 is left on the bottom by itself. So 3 is on the bottom by itself. So 4x squared over 6x is equal to 2x over 3. Those are equivalent. Okay? So if you were using one of the other methods, like you can divide both of these by 2, right? If I divide this by 2 and divide this by 2. What's 4 divided by 2? 2. So that's where my 2 is. What's 6 divided by 2? 3. That's where my 3 is. I have 2 x's here on the top and 1 on the bottom. So I cross this off and this. And then I have 1x on the top and not any on the bottom. So that's another method. Okay? Either one is fine. Now let's do another one, and I'll do this one just a little bit differently. So for this one, I need you to remember that this is 5 times x times x times x to the power of 3, and 15 times 1x. Okay, so first we're going to reduce that 5/15. To reduce 5/15, there are a couple things you can do. You can use prime factorization, you can use common factor to divide them both by the same number, or you can use the upside down division sign. So for 5 and 15, hopefully we all know that these are actually both multiples of 5. So they can both be divided by 5. So for this one, it's easier if you just divide them both by 5. So we're going to divide by 5 here and divide by 5 here. So 5 divided by 5 is 1. And 15 divided by 5 is 3. Now my x's, I can cross off one x and another. Now I have 2 x's left on top. So this is 1x squared, 2 x's, and no x's left on the bottom, so just 3. We do not need the coefficient 1 next to a variable, so we can just say x squared and 3 on the bottom. X squared over 3 is equal to 5x cubed over 15x. Example 3, comparing fractions using a number line. I think this one's going to be the most challenging for you because I know using number lines is not your greatest strength. However, I think working on it could improve that. So, here we have a number line, and what I really want you to focus on is we have -1. It only goes to -1, 0, and +1. Okay? So make sure you write all this down, of course. Example 3, comparing fractions using a number line. Put these in order from least to greatest and draw the number line. Make sure you write the numbers on the bottom. Okay. -1, -1 half, 0, half, 1. All they did was divide 0 and 1 in half from here to here, divided it in half right here, and made a 1/2. Okay. Then, same on the other side on the left. Between 0 and -1, they made a -1/2. Now, why do you think they did that 1/2? Why 1/2? Well, usually students have an easier time finding numbers, cutting numbers in half. So for instance, -3/8. Is a -3/8 less than a half or more than a half? Well, what's half of 8? The denominator, 4. So 4/8 would be 1/2. 4 out of 8 is half. 3 out of 8 then. Is that less than 4 or more? Well, 3 is less than 4. So 3/8 is less than 1/2. So we need to make sure when we plot 3/8 on our number line that it's at the position that is less than 1/2 here. It needs to be less than 1/2. However, since it's negative, that's a little bit different now, isn't it? That's actually greater than -1/2. Because with negative numbers, as they get larger, they actually get less. Like -9 is less than -4. Okay? So -3/8, because it's negative, is going to be greater than -4/8. 1/12. What's half of 12? 6. 6/12 is half. So 1/12. Now that's way over by the 0. That's not going to be close to a half. 5/12, however, is close to a half because 5/12 is closer to 6/12. And 6/12 is close to half. So as you can see, 5/12 is closer to the right, between 0 and a half, and 1/12 is closer to the left, between 0 and a half. And then the last one, 8/7. Well, 8/7 is more than one whole, because if you have 7 and you have all of them, how many do you have? 7. That would be 7 out of 7. But this says you have 8 out of 7, which is even more than 7 out of 7. 8 out of 7 is more than a whole. So we have to go to the right of one whole to plot 8/7. Once all the numbers are plotted on the number line, you could write them in order from least to greatest. So the one furthest to the left is the least. And the one furthest to the left here is -3/8. After -3/8, if we look over to the right, is 1/12. After 1/12, if we keep going to the right, 5/12. And after 5/12, keep going, we have 8/7. So those are the numbers in order from least to greatest. And they're written at the bottom here as well. Another way to do this would be to find, this is another way right here, to find equivalent fractions, to find fractions that all have the same denominator, and then you can just compare the numerator of them to put them in order. Okay? So using equivalent fractions. So when we're comparing fractions, which one is greater, 7/12 or 9/16? Okay? One method, and again you can choose a method, is to use the product of 12 and 16. Remember that product means multiply. So if we're going to multiply 12 and 16, 12 times 16 is 192. Okay? So we're going to use the common denominator of 192 in both of these. 192 in that denominator and 192 in this denominator. So, since I multiplied 12 times 16 here, sorry, one second. Since I multiplied 12 times 16 here, I also have to multiply the numerator by the same number, 7 times 16. So 7 times 16 is 112. And on the other fraction, 9/16 here. So on 9/16, I also had to multiply the denominator 16 times 12. So if you multiply 12 times 16 on the denominator, then you have to multiply the numerator, 12 times 9. You have to multiply them both by the same number, 12, 12. 9 times 12 is 108. So now what's greater, 112 up here or 108 here? 112 is greater. So 7/12 is greater than 9/16. And this is the question, which fraction is greater? So we get our answer down here. Since 112 over 192 is greater than 108 over 192, then 7/12 is greater than 9/16. That's method 1, to multiply the denominators. Method 2, use the lowest common multiple of 12 and 16 to find a common denominator. So, a multiple of 12 is 48. So we're going to change this denominator to 48. And a multiple of 16 is also 48. So we're changing both denominators to the same, which is 48. How did I change 12 to 48? I multiplied by 4. So if you multiply the denominator by 4, you have to also multiply the numerator, the top number, by 4. 12 times 4 is 48, and 7 times 4 is 28. So we have 28 over 48. 28 over 48. On the next one, how did we get 48 here? What did we multiply 16 by? We had to multiply 16 times 3. Well, if you multiply the denominator by 3, you also have to multiply the numerator by 3. So 9 times 3 is 27, and we get 27 over 48 on this fraction. So what this means is 9/16 is equal to 27/48. Those are the same amounts. And 7/12 is equal to 28/48. Those are the same amounts. Okay? So since those are the same now, I can compare these two fractions. Which one is greater, 28 over 48 or 27 over 48? 28 over 48 is greater. So since 28 over 48 is greater than 27 over 48, that means 7/12 is greater than 9/16. Okay? All right. Your guided practice, simplify this fraction. You could use either method. I could divide both of these by 2. 2 over 2 is the same as 1 whole, so I'm not changing the value of the fraction, I'm only changing what it looks like. 4 divided by 2 is 2, 10 divided by 2 is 5, that's 2/5. That's one method. Another method, write the prime factors of 4 and 10. So 2 times 2 is a prime factor of 4, and the prime factor of 10 is 2 times 5. Cross out the common factors, and then you have your numbers that are left, 2/5. And again, the method 3 for 4/10, the upside down with 4 and 10, divide them both by 2. 2 goes into 4 2 times, 2 goes into 10 5 times, and there's my answer, 2 over 5, 2 over 5. So there's all three ways of doing this, 2/5. Okay? Negative 2/6. Again, all three ways. Divide them both by 2 is one way. You get 1/3 and make sure it's negative 1/3 because this is negative. Okay? Negative 1/3. That's one way. Another way, factors of 2 and 6. So we have, 6, sorry. So we have 2 times 1 and we have 2 times 3. 2 and 2 are common factors, so 1/3 is what's left. Upside down division, 2 and 6. This is negative, by the way. Divide both by 2, 1 and 3. 1/3, 1/3, and it's negative. So in all three ways, we get negative 1/3. You just choose one way. I don't want you to write all three of these every time. Just choose one. And 6/8. Again, you're only choosing one. We can divide them both by 2. 6 divided by 2 is 3. 8 divided by 2 is 4, 3/4. Write the common factors, 2 times 3 and 2 times 2 times 2. So the 2's are common. 3 is what's left on top. 2 times 2 is 4 on the bottom in the denominator. Okay? The upside down, a number that goes into 6 and 8 is 2. That's 3 and 4. And there aren't any other numbers that go into 3 and 4. So 3/4 is the final answer. All three ways again. You choose which one works for you and do it your way. 3/15. Divide by 3, divide by 3. 3 divided by 3 is 1, 15 divided by 3 is 5, 1/5. Okay? Or the factors of 3, 1 and 3, the factors of 15, 3 and 5. 3 and 3 are in common. 1 is on top, 5 is on bottom. And the upside down, 3 and 15. Divide them both by 3, 1 and 5. 1/5, 1/5. Again, you get the same answer all three times. Now we have an x. So we're going to write this as 42 times x cubed and 56 times x. Okay? So let's deal with that 42 and 56 first. Use one of your three methods. Okay? For me, I'm going to go ahead and use a common factor. So a common factor of 42 and 56 is 7. I can divide them both by 7. 42 divided by 7 is 6, and 56 divided by 7 is 8. And then I could use another common factor of 2. 6 divided by 2 is divided by 2 is 3, and 8 divided by 2 is 4. So 3/4, there we go. Now the only common factor I have of 3 and 4 is 1. So I can leave 3 and 4 like that now. Okay? So 3/4, and now let's deal with my x's. I have x and x and x, 3 x's on top and on bottom, 1 x. I can cross off my 2 x's here. So now I have 3 and I have 2 x's, x squared, over 4 and no x's. So that's my answer. 3x squared over 4. Number 6, negative. Again, let's take this apart. So I have 30 times r times s over 40 times x times x. So I'm going to deal with just this part first, the 30 over 40. Focus on that. Okay? 30 over 40 can both be divided by 10. Divide by 10, divide by 10, and you have 3 over 4. So I know I have 3 over 4. Do I have anything else in common here? The r, there are no r's on the bottom. The s, there are no s's on the bottom. The x is on the bottom, there are no x's on top, so I can't cross anything else off. So the r and the s have to stay, and the two x's also have to stay. So the only thing I can reduce here are the numbers, not any of the variables. So my final answer is 3 times r times s and 4 times x squared. Negative. Sorry, I forgot my negative sign there. That's very important. Okay. 12 times m times n, and we have another n squared, over 6 times 2m's times 2n's. Let's deal with our number first, 12 and 6. So 12 over 6, I can divide them both by 2. Or by 3 even. Let's divide them both by 3. 12 divided by 3 is 4, and 6 divided by 3 is 2. I can divide them both again then, by 2. And for those of you saying you could have divided them by 6 in the first place, yes, you could. And if you knew that, you saw that, then you should do that. 4 divided by 2 is 2, 2 divided by 2 is 1. Well, 2 over 1 is the same as 2. So there's my number, 2. And now let's cross off our variables. We have an m and an m. We have an n and an n. We have another n and another n. So on top here, nothing left. So just 2. And on the bottom, we have m. So we're going to put this over m. 2 over m. 2 times x times y times z, and 8 times w times x times y. 2 over 8, divide by 2, divide by 2. 2 divided by 2 is 1, 8 divided by 2 is 4. The only thing I have in common on the bottom here are my x's and my y's. So I have a z on top, and on the bottom I have a w. So instead of 1z, we don't need the 1, so we can just say z over 4w. Graph these on a number line. We're going to have, do we have negatives? Yes, we do. 0, negative 1/2, and negative 1. And over here, 1/2. And 1. All right, here we go. 8/9 is close to 1 whole, so I know 8/9 is going to go way over here somewhere. 7/3 is more than 1 whole. It's even more than 2, because 3 goes into 7 more than 2 times. So that's going to be way over here somewhere. 7/3. Hold on a second. It's going to be way over here somewhere, 7/3. But it's negative. Sorry, somebody's knocking at the door and it's distracting me. 7/3 is going to be way over here, sorry. 7/3. And 3/7 is positive, and it's about a half, because half of 7 is 3.5. So it's super close to a half, just a little bit less than a half. So it's going to be over here, 3/7. And 15/18. What's half of 18? 9. So 15/18 negative is also close to a half, right? It's a little bit more than a half. So it's going to be over here, 15/18. Okay? So in order, from least to greatest, least would be negative 7/3, then negative 15/18, then 3/7, then 8/9. Okay? So we have 7/3, negative 7/3 is first. Next is negative 15/18. Next is 3/7. And then last is 8/9. All right, we're going to go ahead and stop there, okay? We'll do some more tomorrow together. Have a nice night.